All right, pre-calc, we're going to get into our right triangle trig. And of course, that means we need a right triangle. Remember, that's 90 degrees. Based on the angle that we're talking about, so here's angle A. So this is going to be the opposite side. We know the hypotenuse is always the longest, and it's opposite of the right angle. So adjacent is the side next to it. SOH CAH TOA, what we're going to add in there is the reciprocals as well. Okay, so to have them lined up, so the reciprocal of sine is cosecant, cosine becomes secant, and tangent is cotangent. Okay, so the easy way to remember, if you have anything issues with it, right, when you want the reciprocal, all right, we're going to change out. So sine goes to cosecant, cosine goes to secant. So we're changing out the s's and the c's. If that helps at all, I don't know. I'm just trying to give you some tips as this may be kind of new vocabulary as we work through it. Here we go. Let's give it a try because we got to become somewhat functional with this stuff. Well, better than somewhat. Okay, so remember talking about so. Okay, so that is sine. So sine of theta. So based on theta being here, what is opposite? Opposite is 8, and the hypotenuse is going to be 10. Okay, so I want to try and make that 4/5. As the note up here, we do want to reduce those. If we're looking at cosine, so cosine of theta, so what's the adjacent side? That's going to be 6, and the hypotenuse is 10 again. These are a little close together. And tangent of theta, that's going to be deal with the opposite, which is 8, and the adjacent, which is 6. So nothing to solve for here. We're just trying to identify how we would deal with this. Okay, so the new ones here, so that's primarily what you're going to use. If we get in a situation where you want to use the inverses, that's fine. But you know how to solve any of these, so it won't really matter. So we use cosecant of theta. Okay, so we're going to say what's the hypotenuse? Hypotenuse is 10 over the opposite was 8. Okay, so it should be what we had up here. So again, I'm going to make that 5/4. As we look at secant of theta, again, I can cheat and say I want 10 over 6. Why didn't I reduce that? So that's 5/3. So this is 3/5. Oh, I didn't reduce this one either. 4/3. All right. And cotangent of theta means we should be looking at 3/4. All right. Came from over here that we did want the adjacent side, which is 6, over the opposite, which is 8. So that gets us a list through there. But like I said, we're going to basically, you can stick to SOH CAH or TOA to get your way through these. The inverses won't really be needed for anything. So what are we trying to do? Rationalize the denominator if we end up doing that, given, okay. So you can use one trig ratio to find all the rest. So let's go ahead. So if this is my angle that I have, this is now the opposite, and this is the hypotenuse. All right, so I'm going to use sine. So sine of the angle, the opposite is 5/6. All right, so this is where we're going to start using our calculator to try and get the angle measurement. What else do we want to do? Use Pythagorean theorem. We'll get back to that. So remember, if I only work with the angle measurement, I'm trying to do the inverse of sine 5/6, and that's going to give me a degree measurement here. All right, so I want to make sure I had it in degree mode right now. We're at 56.4 degrees. Okay, so that gives me an idea of what's going on. We'll just call it 56 degrees for the sake of getting around this whole triangle. So the thing we skipped over is Pythagorean theorem. A squared plus b squared equals c squared. All right, so we know a squared, we don't know. I get 5 squared and I get 6 squared. Okay, so we have a squared 25 equals 36. We're going to subtract, so a squared equals the square root of 11. So we can work with that. I shouldn't have to rationalize anything there. The other thing we can do is we can get rid of our unknown here. So we know this is 56 degrees. So let's find out our last angle is 34, and we found out that this side is the square root of 11. Okay, so keep in mind 9 is your close square root, so 3 point something. So we've finished completing the rest of the triangle, so we can deal with it that way. All right, so what I'm going to do is do some translation here. So if you have sine of theta is 5/7, remember what we're talking about is so. So that means what we know right now is the opposite equals 5 and the hypotenuse equals 7. All right, let's get a little more room and let's figure out what we can do here. So here's what we know so far is we have some right triangle, the opposite, so I'm just going to put that here, the hypotenuse. So what we need to do is find out that last side. So we're going to work with 49 equals 25 plus, we'll call this, this is going to be what, the adjacent side. All right, so we end up subtracting 25, so we're 24 equals, so we need the square root. So the adjacent side should be listed as, we get what, 4 root 6, so 2 square root 6, right? Because we get 4 times 6, so we can deal with it that way. All right, so now that we know all three sides, and we can kind of list them whichever way we want. We know this is the hypotenuse. We're based on this is the opposite, and this is the adjacent. And we have to go through and make our list. So sine is taken care of because that was the given, so we could figure everything else out. So we have so is done. What about CAH TOA? Now what I'm going to do is utilize this space pretty well. So I know that this one's going to become cosecant. And I want to put it here because it should be the inverse right here. Since this one's done, I'll just draw an arrow down. This is what I'm doing. Since this one's cosine, this is going to become secant. And that's going to be HA, secant. So I just got to squeeze these fractions in here. And this is going to be cotangent and AO. So all I'm doing is trying to flip-flop our variables because that's how we make up those inverses. So cotangent of theta equals. All right, so we got to finish out, what do we got? Cosine of theta. That's going to be our adjacent. That's what we solved for, 2 root 6 over top of the hypotenuse, which was 7. We have the opposite, which is 5. The adjacent was 2 root 6. All right, so we have to do a little bit of fixing here because we shouldn't have root 6 in the denominator. So remember how to fix that is multiply by root 6 in the top and bottom. So it's 5 root 6 over top of, what do we got here? That'll make a real 6 times 2 is 12. Okay, so we'll kind of use this, but ignoring all the middle. All right, so now that I have the top row done, that makes this a little bit easier, right? This was sine theta equals 5/7. So this means I'll have cosecant of 7/5. Nothing to fix there. We had cosine of theta, gave me 2 root 6 over 7. So I need 7 over 2 root 6. So we know we have to fix that one. We get 7, 2 root 6 multiplied by root 6. All right, so that's going to be over 12. And we'll have 7 root 6 for a secant of theta. So all we're doing is flipping them over, but we do have to fix that denominator if we have a radical in there. So this one should get fixed automatically because we had to fix it up here with tangent, but cotangent is going to be 2 root 6 over 5 along with that. Okay, so I think that's the easiest way to get this set up just as we go with it. So I do want to find that third side. So I'll try and space this one out a little bit better. So CAH TOA, and that means we want cosecant is going to be HO, secant is going to be HA, and cotangent is going to be AO. All right, I'm running out of space. We'll make it work. I'm going to have to work above there. That's all right. So what do I have? I have cotangent. So this is the one that I have. So cotangent of theta is 4 over 3. So what do I know so far? This is adjacent is 4, and the opposite is 3. So we can start to get this whole thing taken care of. So adjacent might be 4, 3. Look, it's a 3, 4, 5, right? So the hypotenuse is going to be 5. All right, so I'm assuming theta is here. All right, if you rearrange it, we'll have all the same stuff the other way. So that means tangent of theta is going to be 3/4. And we'll work our way over here. So cosine, the adjacent was 4. And the hypotenuse is 5. Sine of theta, the opposite was 3. The hypotenuse was 5. So that means the cosecant of theta is going to be 5/3. And the secant of theta is going to be 5/4. All right, so that's kind of our way to get around those. And you're going to go with probably what you know, what you really are familiar with is SOH CAH TOA. All right, and then what we can do is relist them knowing that these are inverses. Okay, so there's going to be some vocabulary to get into and how to deal with some of those things. All right. I think the last couple that we have here are really just kind of hopefully review. So that was the tough part. Okay, guys. We just want to work through and figure out everything else in our right triangle here. So we know that we have 57. So that gives us an answer right away. We can fill out, this is 33 degrees over here, right? 180 on the inside here. And all that I know is that I have a AC, in this case, it's the hypotenuse, is going to be 12. So we're going to figure out some things we don't know. So I might just list this as X and this is Y. Knowing that X, if 57 is the one that was given, in case I made a mistake here, I want to use this one. So if I have a hypotenuse, X would be the opposite. Okay, so I know with opposite and hypotenuse, I'm going to use sine of 57 equals X, I don't know, over 12. Okay, so we can do the sine of 57. Okay, and that's going to be about 8.3. So if you're making sure you're in degree mode here, and then times 12. Okay, so we're going to get 10.06 over here. And then if I'm still going to use this one, this is now the adjacent side. So if adjacent and hypotenuse, remember that's going to be cosine. Cosine of 57, in this case, y over 12. So cosine of 57, and then times 12. All right, so we find out the adjacent side is going to be 6.54, if I see that correctly here. And we just want to make sure that our angles and sides all match up. Okay, not drawn to scale or anything like that. So that's what we have going on here. All right, so really it goes back to labeling. And we want to make sure we find out anything that we need to find here. So if we have 55, this must be, based on this angle, this is opposite. And we're trying to find the adjacent. Okay, so opposite and adjacent, that's TOA, right? So tangent of 55 equals 29 over X in this case. Okay, so we're going to end up cross multiplying. So to get this, I'm actually going to do 29 divided by tangent of 55. And we'll find out that this is going to be 20.31. All right, so we can use Pythagorean theorem and find out what's happening here. We'll square it, plus 29 squared. And then we're going to take the square root of that answer. And so we find out the hypotenuse is 35.40. And of course, our missing side here, 90 minus 55 is 35 degrees here. So we get all these things taken care of. All right, one more down here, and then just some extra practice after that. So it's based on the based on the angle that we have. Okay, so this is now the opposite, and this is of course the hypotenuse. So if I have the opposite and hypotenuse, what's that have to do with? So sine of 19 degrees we have opposite over hypotenuse, sine of 19. We're going to do times 29. Okay, so this opposite side should be 9.44. All right, so we can do Pythagorean theorem. We're going to find our missing side, and we know 90 minus our 19 is going to come out to 71. So 71 degrees here, and then we're going to use Pythagorean theorem. So 29 squared minus 9.44 squared is going to give us, what is this? This is the opposite side. Nope, this is the adjacent side. So I might treat it that way so I know exactly what I'm solving for. So 29 squared minus 9.44 squared. Okay, and then we want the square root of that answer. All right, and it looks like it's right about 27.42 for the length of side. Okay, I just want to make sure certain things happen. The hypotenuse is the longest side. We know that there should be some sort of ratio going along between the angle and also the side length. The bigger the angle, the bigger the side length. That takes care of those as well. All right, so we have a couple things to practice just where everything's located here. If you're in my class, this will be in your OneNote page. There's also some more formal problems listed up here as well. Not too much, but enough to be dangerous.